Good day. In this video, we're going to prove these 5 identities using compound angles. It's part of the grade 12 syllabus. Before we start with the proofs, there's a few things you must remember. Firstly, you must tell yourself, I can do trigonometry. Secondly, you must remember there's a lot of algebra in trig. You must know and learn 3 sets of identities. Firstly, the grade 11 identities, these two. Then the compound angle identities, there are 4 of them in that red circle. The third set is the double angle identities down here. There actually is only 2, although this one's got 3 friends. Then also, I must keep the left-hand side and the right-hand side separate and then later together. The first question says we are required to prove that this is equal to this. There is no rule that says you must start on the left or the right hand side, so I usually start on the side that looks the most complicated to me, which is this one. But you would like to start here. But the basic rule is you might have to adjust this guy to a certain stage, adjust this to a certain stage, and eventually they look the same. Sometimes you're lucky, you can adjust this one and it eventually looks like this one. You adjust this one and it looks like this one. But in short, let's not make any extra rules. I'm going to simplify this one, and see if we can get them to look the same. You have to write wherever you start. I started with right hand side equals, and I copied this down. Then from my grade 11 identities here, I know that tan theta is sine theta over cos theta, so I'll change both of those. Then it will look like this. I knew that this tan theta was going to become a fraction, sine theta over cos theta. Then I changed everything to fractions close to it, that I can use my fraction rules afterwards. The next rule says we must work out the top separate from the bottom and then divide them into each other. But this is compound fractions. I like to pull the top off, put a divide, and write the bottom down. I already simplified the top up to here. Like I said, we're now going to simplify this bracket first. The first thing I see is I've got common fractions here that I must add, so I write my LCD with a long line. You say, what do I times 1 to get to cos squared? Then I times the same at the top. Then I say, what do I times cos squared to get to cos squared? That is 1, so I times this by 1. You get plus sine squared theta. So at the top here we have cos squared theta plus sine squared theta. Now I have a unit here and a unit here, and fractions divide says I must tip and times. Now up here I can see I've got a cos squared theta plus sine squared theta, which is my grade 11 identity, which is 1. So I can change that top to 1 before I tip and times. Then my right hand side will look like this. Now I can cancel. Cos goes into itself once, and I can cancel that square up there, which will leave me with a cos theta up there. Now I can just multiply, which will give me 2 sine theta cos theta over 1, which I don't have to write. And that's equal to sine 2 theta, which I wanted. Then you have to write left-hand side equals right-hand side. Please stop the video and get your brain around this one. It is our second proof. It says required to prove that this is equal to that. Inside here we have a compound angle, and here we have a binomial times a binomial. Here you can write left-hand side equals and write it down. Then we write 2 brackets next to each other. Use the distributive law and times it out. So sine theta times sine theta gives you sine squared theta. Sine theta times plus cos theta gives you plus sine cos theta. And then by timesing the cos theta with this term and with this term, you'll get these 2 terms. Then you can simplify this. Sine squared theta plus cos squared theta gives you 1 from our identity up here. And we add these 2 terms, we get 2 sine theta cos theta. Then we keep the 1 and 2 sine theta cos theta from our identities. We know is sine 2 theta. Then you just have to write left-hand side equals right-hand side. It is our third question. It says here, we have required to prove this is equal to that. Here we have a tan square x, friend of that one. And here we have a cos 2x, a friend of these three. I started with the left-hand side, and I wrote left-hand side equals to 1 minus tan squared x. The tan squared x changes into sine squared x over cos squared x. Because this is a fraction, I immediately make this 1 also into a fraction. Now I can do common fractions plus and minus. I write down my LCD, cos squared x, and a long line on top. Then I say, well, what do I times 1 to get to cos squared x? That's cos squared x, also times the 1 with cos squared x, and that's what I get. Then I ask, what do I times cos squared x to get to cos squared x? That is 1, so then I times this by 1, and I get minus sine squared x. Then I keep my bottom, and I change this to cos 2x. Then you can see it's the same as the right-hand side. Then you just have to write left-hand side equals right-hand side. So here is our fourth problem. We have to prove that this is equal to that. I especially put t's over here. Do not get confused by that. In this case, I started with the left-hand side again. I wrote left-hand side equals, and I copied this down. Sine 2t is one of our identities, so I converted it to 2 sine t cos t over 1, because I know there's a fraction coming here. Tan t, we convert to sine t over cos t from our identity. Now we have a common fraction plus and minus question. You put your LCD down, cos t with a long line. You ask, what do I times 1 to get to cos t? And I times that also to the top. So 1 times cos t gives me cos t. Then timesing it to the top will get me this with the cos squared t standing here. What do I times this bottom to get to this bottom is 1. So I times that by 1, which gives me minus sine t. I told you these sums are full of algebra, so now we're going to factorize. Keep the bottom, and at the top there's a sine t and a sine t common. So I pull out a common factor, sine t, and then I'm left with that. Then we are actually finished. But if you can't see that, you say, listen, I'm a little bit confused. Let's go and work with the right-hand side and see if it gets here. Then I wrote here right-hand side equals and copied it down. Then the tan t becomes sine t over cos t. And oh yes, cos 2t. There he's standing. I can just write him down immediately. Then we just write left-hand side equals right-hand side. Please stop the video and get your brain around this one. Just some advice. Never try and copy an identity down from somebody else and then try and memorize it, because the next sum looks different again. This is just to show you a few sums and how you can work yourself out of there with a method. There's about 4 ways I could have done this question. So be relaxed, be creative. Let's look at the last one. Right, and here we have our last and fifth problem. It says, required to prove that this is equal to that. I started left-hand side equals and copied it down. Converted the tan a to sine a over cos a in both of them and immediately made those fractions. Because it's compound fractions, I pulled them off each other, bracket around that, put it down, divide over there, bracket around that, down there. Common fractions minus, common fractions plus. Keep the divide. Wrote down the LCD like one of our previous questions, worked out the top, kept the divide. Wrote down the LCD, worked out the top, like we did previously in this video. Now we have 2 loose units that we can tip in times. Then we do fractions multiply. I cancel, cos goes in itself once, cos goes in itself once. Then I times the top with the top and the bottom with the bottom. Then we get cos a minus sine a over cos a plus sine a. Doesn't even closely look like this guy. So let's take him and work on him. So then I wrote down the right-hand side. Then I can change this top to cos 2a. I can see him standing there at the identity. I keep the plus 2 sine a cos a. Change the 1 to sine square a plus cos square a. Then I change this cos 2a now again to cos square a minus sine square a. And I keep the sine squared a in the beginning and move this guy to the back. Then I have a trinomial that I can factorize, and I have the difference of 2 squares up here. This is not an easy move from year to year to understand that I can change this 1 and make it even bigger to help me to make it better. You'll see now where it goes. This specific move, you change the 1 to sine square A plus cos square A, is used in equations also. So don't be too upset about this move. I then factorized the top and the bottom. Then you cancel this cos A plus sine A with a sine A plus cos A. Then you will see that you have your final answer available that you have over here. Do not get upset because this sine A plus cos A is the other way around. Top looks right. Without any calculations, I just rewrite it to look like this one, and I just say left hand side equals right hand side. Please stop the video and have a good look at this last one. They usually don't ask them this complicated, but can definitely be asked. Please indicate whether you liked or disliked this video and subscribe to the channel. If you run into any school trig identity that confuses you, you can send it with a clear WhatsApp photo to this number, and also where you tried it. Then we will try and solve the problem for you and send back an answer as soon as possible. Enjoy the trig identities, grade 12.